All right, 8.1, we talked about the basics kind of behind hypothesis testing. Now in 8.2, we're going to put that information to work. I got a couple other little things just to give you a heads up on, but really 8.2 is actually performing hypothesis testing. Okay, so just a quick review. Remember those 4 steps. Step 1, state the hypothesis. Step 2, preparation. Step 3, compute and compare. And step 4 is to interpret. So I've got a little bit of extra information about 2 and 3 and 4 that I need to give you. And we're going to do this. Okay? So a couple of extra details in step 2. So in step 2, it's all about the preparation. So remember how we talked in 8.1, the first thing is you're going to choose your significance level. Unless told otherwise, your significance level is 0.05 by default. Okay? Unless told otherwise, it is 0.05 by default. All right? So there's your significance level. Right now, our test statistic is a 1 proportion Z test statistic. 1 proportion Z test statistic. So in StatCrunch, you'll go under Stat, Proportion Stats, 1 sample, and most of the time we're going to be doing it with summary. So Stats, Proportion Stats, 1 sample, and we're going to be doing it with summary. On the TI-84 calculator, you'll go Stats, Tests, and you're going to do number 5, 1 proportion Z test. Okay? So number 5 is the one that we want to run. Okay, and that's under statistic, and you scroll all the way over to tests, number 5. All right? Okay, so jumping back in here. So we've chosen the significance level, we've chosen the test statistic. The last thing you're going to be doing is you're going to check the central limits theorem to make sure that we can do the normal distribution, because anything that passes the central limits theorem is normally distributed. Okay, so again, when we did the central limits theorem, there were 3 things to check. For us, they actually made them into 4. They've separated the first 2. Okay, so random and independent is now 2 pieces, but you can really kind of do them together. So is our sample taken randomly, and are the observations independent? And then we check large sample and large population, just like what we did before. So that's kind of the details I wanted to talk to you about. These are the checks that we got to do in the preparation. Because as long as this checks out, under the appropriate conditions, our sampling distribution of the Z statistic is approximately normal. Okay? So we can compare and get our information from a normal distribution. All right? Okay. So there's the details about step 2. It's really about checking the CLT. Okay? Because that allows us to do all the normal information. So let's talk about that right here. In your assignment, they're going to have you check information like this. So a 2003 study of dreaming found out that a random sample of 113 people, 92 reported dreaming in color. However, the proportion of people reported dreaming in color that was established in 1940s was 0.29. Check whether the conditions for using a 1 proportion Z test are met, assuming the researchers wanted to see whether the proportion dreaming in color had changed since the 1940s. Okay? So we don't have to worry about the hypothesis. We want to check CLT. Go ahead and pause the video and check it now. Okay, so we know that it's random. Okay, so part 1 of CLT is met. It's random. Part 2, is this independent? Well, hopefully my dreaming in color does not affect your dreaming in color. Okay, so we're going to have to assume that our observations are independent, because my dreaming should not affect your dreaming or anybody else's dreaming. Okay? So first two, generally, we can assume that they're true because usually if people are performing a study, they want to make sure that they're performing it in the best possible means, which means they're eliminating bias. So that's that simple random sampling, the SRS that we talked about before. So that's that step one there, SRS. I'm pretty sure they're doing that. And no one's dreams should affect anybody else. The big thing that you're checking for them is you're checking on 3 and 4. You're checking the sizes. So remember, we want to check success versus failure. And we need to make sure that we have at least 10 successes and at least 10 failures. If we don't, then we don't do hypothesis testing. Okay? So we want to take 0.29 and we want to multiply that by 113 times 0.29. And I don't know why I'm doing this in red. I need that to be in blue. Blue. There we go. So is this greater than or equal to 10? So if you go to your handy dandy calculator, 113 times 0.29 is 32.77. But again, we don't know what 0.77 means, but that is definitely at least 10 successes. Failures, we'll take 113 times 1 minus 0.29. And we want to know, is that greater than or equal to 10? So 1 minus 0.29 is 0.71. So 113 times 0.71 is 80.23. So we definitely have 10 successes and 10 failures. Okay? So this one met. Now all we got to do is just double check the population. And again, this is kind of one of those things where you don't really know the total population, but we can talk about the population in general that we're dealing with. Okay? So step 4, let's talk about large population. So our main population, it says we were studying people, just people. So in other words, we're talking about people. So our population is people. We want to know, is that greater than or equal to 10 times our sample size? So 10 times 113 is 1,130. So the amount of people, let's just say in the world, is that bigger than 1,130? And hopefully you agree that it is. And so, obviously, this is met. So the people we're talking about is those that dream. So do you think that there are more than 1,130 people in the world that dream? Absolutely, I think so. Okay, so conditions are met. Everything is all good. CLT is good, and that means we can proceed with the rest of our hypothesis testing and use normal distributions to help us out. Okay? So some of your assignment's going to be like that. You're going to just check what's going on. All right, step 3, couple details in here. So this is the computing. So I've already told you how to compute the Z statistic, okay, the Z test. We did that in 8.1. Now in here, I want to talk a little bit more about what does as extreme as or more extreme than mean, okay? So what does as extreme as or more extreme than mean? This is talking about the repeatability of this situation. Okay? This is talk about the repeatability of this. And again, this is all about the p-value. Because remember, that's the probability that is that the value happens as extreme as or more extreme than this. Okay? So this is all about the p-value, which is what I want to talk about in step 3 anyway. So this as extreme as or more extreme than. Well, first off, it depends on the alternative hypothesis and the repeating of the sampling, like I said. Okay, remember our alternative hypothesis comes at us 3 different ways. It comes at us in the not equal, okay? The not equal. It comes as the less than, and it comes as the greater than, okay? So when it is not equal as the alternative hypothesis, okay, the as extreme as or more extreme than means that if we repeat this, our observations will be even further away from 0 than the value we observed. That's what that means. Okay? So in the an example that they had in the previous one was we had a person telling the difference between Coke and non-Coke, or between 2 different sodas, as it was. Okay? If the hypothesis test was not equal, then that means, and I think in that example we had 13 out of 20. Okay? So that hypothesis test means that if we repeat this, we would get a new z value that's further away from 0 than the value we observed for that 13 out of 20. Okay? So if we repeat this, we're going to get a new z statistic, and that z statistic will be further away from 0 than the value we observed. Okay? That's what it as extreme as or more extreme than means in the not equal. That if we repeat it, we're going to get something either the same as or even worse. Okay? And then keep that in mind as we go through the next piece. So if we want the less than version, so as extreme as or more extreme means that if we repeat it, we'll get a z value less than or equal to the observation. Okay? And then if it's greater than, you'll get the as extreme as or more extreme means that you'll get greater than or equal the observed value. So if we're thinking about the Coca-Cola problem or soda pop problem, 13 out of 20, if it was a less than version, it means that if we repeat this, we will get less than 13 out of 20 or equal to it. That's what this means. If we're doing the greater than, then that means we will recognize 13 or more if we repeat it. Okay? So that's what we mean by as extreme as or more extreme than. It's all about that hypothesis testing telling you what's going to happen and the repeating of the sampling and what should happen with it. Okay? So there's as extreme as or more extreme than. That's what that means. Okay? And then last but not least in here, how do we find the p-value? It's the same way we found the p-value when using the normal distribution as what we did in chapter 6 when we learned about the normal distribution. Okay, we can use the table on the back, or we can use technology. You know, you've already learned how to use the table. Let's not worry about that. Let's only focus in on the technology. Okay? Because again, in chapter 6, we already talked about how to use the table to help us out. All right? So I want to focus in on the technology and get right to, right to the point. So that's a little bit more about step 3 and just talking about this as extreme as or more extreme than. Okay. So right here, we got a couple questions. So it says, for each graph, indicate whether the shaded area could represent a p-value. Explain why or why not. If yes, state whether the area could represent a p-value for a one side or a two side. Okay. So go ahead, pause the video and see what you think. Could this represent a p-value for us? Yes or no? If yes, tell me, is it a one side or a two side? And then repeat the same thing for this guy. And go. So, part A, the answer to this one is yes. This represents a p-value for us. Okay? And it is the two-sided, or sometimes we call this two-tailed. Okay? Because it has two tails. Tail, tail. Okay? Part B, this one is a no. You will never be stuck between two guys in here. We call these hypothesis testing, but sometimes we call, you'll hear me say, what kind of shading is this? Is it a one tail or two tail? Or one side or two side? Hypothesis test graphs either look like this or they look like a one-sided. So that's a one tail. And that's a one tail. Okay? One tail, which means that you're working with the greater than or equal to. Actually, no equal to, just greater than. Over here, this is the less than version, and it's a one tail. Okay? We can find the p-values for these guys. But this guy right here, no. We will not have a hypothesis test that looks like this. Ever. Okay? So there you go. Just a simple question about p-value and, what do the graphs look like when you do a two-tail or one tail. Simple. Easy peasy. Okay? So right here, again, they've already done some work for us. Okay? They want you to report and interpret the correct p-value. I feel like I missed something for a second. Let me just go back and double check. Nope. Still on step 3. Okay. So we want to report and interpret the correct p-value. Okay? So here is ha. All right? So let's just read this real quick. When asked whether marriage is becoming obsolete, 782 out of 2004 randomly selected adults answered a Pew poll said yes. So we are testing the hypothesis that the population proportion believes that marriage is becoming obsolete is more than 38%. Our significance level is 0.05. So one of these two pictures represents this. I think it's only two. Yeah. So let's go ahead and let's make this the entire page. Which picture represents this one? Is it the two tail or the one tail? And hopefully based off of what we just talked about, you said that B is the information we want. So that's the first part. We've indicated the graph that matches. Now, part 2, we want to report and interpret the correct p-value. So they're going to ask you to tell us the p-value and make sure that you round accordingly, because sometimes it says 2 decimals, sometimes it says 3, sometimes it says 4. Like, you'll report the whole thing. Okay? And this one, I think they are having us report as 3 decimals. So you would say the p-value, easy peasy, is 0.173. Okay? Or if you remember, this is a probability, you can call this 17.3%. And again, we've kind of talked about this in the previous section. So if we want to write what this means in terms of the problem, this is where we're getting that as extreme as or more extreme than. Okay? So since we are dealing with the greater than, in our terms, we want to say that it's greater than or equal to the observed value. So what we're going to say on this, we're going to write it up right here, is that if the population, and again, the cool thing is you will not have to type this from scratch. You'll have multiple choice there to help you out, or it's like fill in the blank at the same time too. If the population proportion that believe marriage is, oops, missed an R, obsolete, maybe that was wrong. And this is why I'm a math teacher, not an English teacher. Okay? So if the population proportion believe marriage is obsolete, there is about a 17% chance of getting 782 or more, see there's that or more, out of 2004 randomly selected adults who believe that. Okay? So there is the reporting out. So again, this probability that if we repeat it, we have a 17% chance of getting 782 or more out of 2004 who will believe that. Again, remember, as I said, this is all about the repeatability of this. So use these words to help you out, okay? So we believe that we're going to get more out of the, we got a 17% chance that we will go over this value, okay? Hopefully that kind of explains the as extreme as or more extreme than a little bit better in here than what it did in 8.1. Okay? All right, so step 4. Couple pieces of information in here about the interpret. So how do I know when to reject or accept? So this is all about that p-value, so it's important. So you will reject the null hypothesis when the p-value is smaller than or equal to the value chosen for the significance level. This is why that significance level is spoken in part 2. Okay? So you will reject the null hypothesis when the p-value is smaller than or equal to the value chosen for the significance level. We will accept the null hypothesis when the p-value is larger than the significance level. Okay? So, if we went back to this, just kind of using this as an example, our p-value was 0.173. Our significance level is 0.05. So is this larger or smaller than that? This is larger. So based off of what I just told you, because the p-value is larger than the significance level, you're going to accept the null hypothesis. So we are going to accept that 38% believe that marriage is obsolete. They were testing that it was greater than that. But there's not enough evidence to support that. Okay? There's not a statistical difference there to support it. Okay? So, when the p-value is smaller than the significance level, reject. When the p-value is larger than the significance level, accept. All right? So it's time to do this. Okay? It is time to run a hypothesis test. And I believe I have 2 of these. Yeah. So right here, they have ran the hypothesis test for us. And they want us to carry out the 3rd and 4th steps. Okay? So they want us to do the compare, because they've already done the compute. And they want us to interpret. Okay? So you can see our step 1 is right here. There's the null and the alternative. Okay? So and we have stated our significance level. There's our significance level. That's alpha. Remember, we use that for significance. And also know that this is a z-stat that we ran here. So again, we know that it's a 1 portion z test statistic that we ran here. So that's all of part 2 right there. And of course, because they ran this, that means that they hopefully have checked the CLT, which they have. Okay. All right. Now, step 3 says to compute. So our z statistic if you read up here, it's right here under z-stat. So it is negative 3.6091246. They probably have you round to 2 decimals because most of the z statistics are rounded to 2 decimals. So they probably said negative 3.61 as the answer. Okay. Now you could take this, and this is a 2-tail. So if you wanted to, you could go and use the table that's on A-2 and A-3 and look up the excuse me, the probabilities for this. I was losing my train of thought. Okay. And so if you look at the probabilities for this, you'd actually be looking at negative 3.61 and a positive 3.61 because this is not equal to up here. So that means it is a 2-tail or 2-sided. Okay. So, and then what you would do is you'd find the probability to the left for this guy, find the probability to the right for this one, and add those 2 up. Okay. Sorry, that's my daughter yelling in the background if you can hear. So the left probability plus the right probability, that gives you your p-value. Or again, as I'm going to show you, just use the information from the calculator. Okay. So right here is the p-value that we're after. So that p-value is 0.0003. Okay? So those are the compute parts. That's really what they want you to do. Okay? And so now we're going to compare this to the significance level. So the question is 0.0003 greater than or less than or equal to the significance level, which was 0.05. So which one is it? And it is less than. So now we enter the interpret phase. Okay? So in the interpret phase, the first thing you're going to say is that you're going to reject the null hypothesis. Okay? So that's the first thing that you want to do on this. Because if you remember, when the p-value is smaller than or equal to the chosen significance level, we reject. Okay? So down here, oops, come here, you. Need you to expand downward. Ugh, come on. There we go. What is typing in green? Move this over. So we are going to reject H not. Okay? Should I turn that off? I didn't. There we go. So reject H not. And in terms of the problem, the proportion, sorry, losing my, that sleep walk is significantly different from 0.33. So when we reject it, that means we have significant differences. Okay? If we don't reject it, then there are no significant differences. Okay? So when we reject it, that just means that the proportion is significantly different from what they stated. Okay? Which means that it's something else. It might be higher, it might be lower, who knows? But we know that we rejected this because there is significant difference. Okay? So that's what the interpret phase is kind of like. So with that being said, here it is. So everything in here is all about getting you through the hypothesis test. So you're going to start at the beginning and you're going to go all the way through. And go. Okay, so the first thing is we need to state the hypotheses. So we need to state H naught and ha. So H naught and ha. And then I'm going to show you how to run this in the calculator. So according to the source, 50% of plane crashes are due at least in part to pilot error. So that means our H naught is P equal to 0.5. Suppose that in a random sample of 100 separate airplane accidents, 62 of them were due to pilot error. Okay? So part A says test the null hypothesis and that the proportion of airplane accidents due to pilot error is not 0.5. Use a significance level of 0.05. Okay. So if it is not this, then that means they are telling you this is a not equals, because it's not saying it's greater than that. It's not saying it's less than that. They just say it's just not this. So here we have our H naught and our alternate hypothesis or alternative hypothesis. Okay, so that's step one. Step two, we're going to do all the checking. Okay, we already know that we're going to run the one portion Z test. We already know that alpha is equal to 0.05. But let's check everything for CLT. I don't know why I wrote CLL. That's just weird. CLT. So 1, is the sample random? Yes, right here. Random sample. So we know that works. And on that, we also know that each plane should be independent of each other, because that first plane accident should not affected the second plane accident. Okay? So we know that they're independent. We can assume that. So step 3, we want to check successes and failure. Hopefully you were checking all this, because this is the full gambit. This is what's got to happen. So we're going to take, I believe we had a total of 100. So we're going to take 100 times 0.5. And we want to know, is that greater than or equal to 10? And absolutely, because that's 50 greater than or equal to 10. And then we're going to do the same thing over here. We're going to take 100 times 1 minus 0.5. Is that greater than or equal to 10? And yes, it is, because that's 50. Okay? So successes is met and failures. And then 4 is the population bigger than 10 times our sample. So in other words, have there been more than 1,000 plane crashes? That's the question. And yes, there have. So our population of plane crashes is definitely over 1,000. Okay? So step 2 is good to go. Everything is stated and CLT is met. Step 3, let's do some computing. Okay? So we're going to get the Z statistic. We're going to get the p-value. Okay. So let's talk, how do we do it on the graphing calculator first? So the first thing you're going to do, just like what I said, go to Stat, go over to Test, and you're running number 5. 1 prop Z test. Okay. Hit enter. You're going to put in your p-value, which is 0.50, or you can put in the full thing, 0.50. You're going to put in your total, which you can see that I've done some other ones, kind of just playing around with these. And our total, or sorry, the number of successes. So there were a total number of 62. So that's our X. This is our N. Okay. So we go back to this. So 62. N was 100. Now you come down here and make sure you select the correct one. What was our HA? and our HA was not equal. If our HA was a less than, then I'd scroll over here and select less than. If our greater than is already selected. So you'll know which one is selected because it'll have a black box around it. Because we are not equal, I'm going to hit enter and see now you can see that not equal is selected. You can choose your color, doesn't really matter, but we can calculate or draw it. Okay? Let's show you what draw looks like. So there's what the draw looks like. Okay? And that's the one I would do. Okay? If you did calculate, I'll go back, show you what calculate looks like. Oops. Stat, test. If you just went down, it's all the same information. It doesn't change until you change it. If you just hit calculate, then it gives you everything. There's the Z, there's the P value. Okay? There's your P hat, and there's your N. Okay? But again, we like to look at the draw because they do like to look at the pictures, and they generally ask you what the picture of the tail looks like. Okay? So we go back in here, and I'm going to have it draw it. Yay, there it is. So if we report out, our Z statistic is 2.40 because it probably wants 2 decimals, and it probably wants the 4 decimals for this, 0.0164. So our Z statistic, 2.40, and our, excuse me, our p-value, 0.0164. 0.0164. Okay? There you go. That's how you do it on the calculator. Let's talk StatCrunch. Super easy. In StatCrunch, you'll go to Stat. You will go down to Proportion, just like what we did back in Chapter 6. Okay? And, sorry about that. Proportion, one sample. Oh, come on now. Proportion, one sample with summary. Put in your successes, 62. Put in your observations, 100. And then now, remember how before, actually this was in chapter 7 when we did confidence intervals. Remember how we selected confidence interval? Okay, so here we're going to keep it on the hypothesis test. You need to put in your H naught. And then you need to, right here, this will either give you the not equal, the less than, or the greater than. So make sure that you select the correct one. Okay? So make sure that hypothesis test is selected. Put in your H naught. Okay? And then once you put in your H naught, it will change this number if it's different. And then you'll come over here and select whether it's the not equal to, the less than, or the greater than. Okay? And then hit compute. And so right here, it doesn't give you a picture. So in this one, the calculator probably a little bit better, not, okay? But here's all of our information. Okay, here's that significance level. Okay, I think that's our significance level. Or sorry, let's go back to edit. Let's double check that. Nope, sorry. So don't think of this as a significance level. Just kind of coincidence that it is. But you can see the Z-stat, you can see the p-value, you can see our p-hat, just like what the calculator gave you. Although the calculator, a little bit better because it actually gives us the picture of the test. Okay? So again, there's all of our information right there. And that's how you run it. So again, just kind of going back through that, since you kind of saw a lot, you go to Stat, go to Proportion, one sample with summary. Okay, and you've done that before. Like I said, we did it in chapter 7 when we were doing confidence intervals. Okay, but instead of selecting confidence interval, you're just going to keep it at the p-hat. Make sure you put in your H naught and your HA. Make sure you select the right symbol and then hit compute. So again, 62, 100. It is 0.5. It is not equals. Compute. Okay. I think it might graph. Let me look here. Yeah, you could actually have it graph. So if you select the graph down here, and wait, oh, push the next. There's your graph. Cool beans. The calculator, yeah, I mean, it's kind of just like the calculator in here. In the calculator, you can just have it give the information, like what this guy did, which is what our calculator can do when it says calculate, or you can actually have it draw it by, in the options, selecting p-value plot. And again, you just scroll to the next page, and there it is, the two-tail. Cool. All right. So there's that information. So there's our step 3. And in step 3, we also are going to do that compare. So our p-value was 0.0164. The question is that greater than, or is it less than or equal to 0.05? So based off of that information, hopefully you selected the less than, or equal to. And then now we can go into step 4. And we can talk about the interpretation. Which the cool thing in step 4 is they already gave us our interpretation up here. It's one of these two. But before we do that, I want to know, do you reject or do you accept? And according to this, in step 4, you would reject the null hypothesis. Okay? So in this case, we would reject. Because again, going back to this, when the p-value is smaller than or equal to the significance level, reject. When we're above, accept. Okay? Actually, did I say that on this? So hopefully I said we would accept on this one because our p-value is definitely larger than the significance level. I think I might have said reject. That would have been my fault. But we would accept on that example. All right. Okay. So last thing is, give us the correct interpretation. So which one of these is it? So hopefully you selected number 2. Because when you reject, that means there is significant differences. Okay? So the percentage of plane crashes due to pilot error is significantly different from 50%. All right. So section 8.2 are questions 29 through 42. 8.3, we're going to talk a little bit more about some more details into this stuff, some watch out for and things like that, some observations that we can make based off of what we know. And then 8.4, we're going to talk about a 2-population T-stat, or Z test statistic, I should say. Okay? So that's what 8.4 is about, when we have 2 different populations. So have fun with 8.2. See you next time.